Right. Hi there. My name is John McMaster. I'm a chip enthusiast here in my Silicon Valley garage.
Hey, and I'm Yusuf from Geek Monitor.
Hi there.
Hey, John, so, in episode 2, we talked about designing and prototyping and actually CNC machining a metal part, which I hear you got from the company this week.
Yeah, so let's give a quick bit of overview about what the project was. So the basic idea is I have these high precision polishing machines, and they have these sample holders that look like this, and you can actually see some chips mounted on there. And the idea was I need to make some custom adapters, and these are very expensive. So I was looking to see, could we make a copy? And what was the answer?
Yes, we could.
That's right. Thank you, Bob the Builder. So here we have, first thing you did was you designed this part. Can you tell us a little bit about what this guy is?
So that I designed it in Fusion 360, which gave us a 3D model, and then you use that to 3D print that part that you're holding to go ahead and fit test it.
That's right, yeah. So this was printed at the UPS store in downtown Mountain View. And then that allowed me to do a fit test and verify these were identical. But then the next stage of that was these were probably not going to be precise enough, given the very high tolerances on this machine, let's say within the order of 2 micrometers. To give you a rough idea, a lot of machine parts are machined to tolerances of about 50 micrometers, so considerably more precise. And this right here is one of these CNC machined parts we got back, and this was using Xometry. Have you used that service before?
I didn't use it, but you have, right? Haven't you in the past?
I did. I had a little bit of a mixed results of them, but they convinced me to give another try. So here are the parts right here, and yeah, I mean the quality seems okay. It's one of the things that I'm really interested about is the different surface qualities. So one of the things that really amused me is you see this surface is relatively flat, let's call it matte. I don't know if the right word would be shiny. It's relatively shiny. Like there's not a lot of texture to it. You don't really see the tooling marks so much, I guess I should say in particular. Now, if you look at the other side, do you see all the tooling marks there?
Yeah, and does that actually catch on your nail? Like, is it just like
No,
very thin marks?
like I can maybe barely feel it. What I suspect is that they milled it. So this is a mill finish, that they milled both sides, and then I think to get the height tolerance, I think they essentially ground this down until it met tolerance. And that's the reason why this side is shinier than the other side, but I'm not quite confident about that.
Does it look like maybe it's a surface finish on a lathe?
No, this is definitely milled. So I don't know how hard it's easy to see, but
Yeah,
like
it's a little blurry. It's a little blurry on the camera. Those lines are easier to see. Yes.
yeah, so the other side has the same thing. It's just been polished down, and so it's only just visible. But that was only a stepping stone. Do you remember what I wanted to do after I got this?
Yes, you wanted to put on your machine and grind some chips down.
Yes, but before I could do that, this is a very precise piece of equipment. So even if it was working well and you moved this piece of equipment, it knocks things out of alignment. So what do you need to do if something's out of alignment?
Measure, measure, measure.
That's right. And that's where this piece of equipment comes in. So what the basic idea was is I took one of these blanks and I fitted a little stud in here that allows me to hold this very precise feeler gauge. And I don't know if you can read the increments on there in the video, but each one of these divisions is 2 micrometers, which is quite precise. And so by sticking this on here in actual operation, what it does is this slots in like this, if you can see that, and then I use my thumb to tighten it. And then this now is mounted onto the machine like this. And this little feeler, if I put this down like this, goes onto the precision surfaces of the machine, and I can move the head around and measure things like, is the plate flat? If I rotate this on the machine, does it stay level? That may mean that this has some sort of tilting offset or other imperfections.
Now, the little holder, the little cylindrical holder, the hole for that wasn't there initially in the design. So how did you get that in there?
Yeah, so what I did was the exact position of this hole was not that critical. So I just kind of eyeballed it on my milling machine, and I took a center drill. Are you familiar with those?
Yes, like a drill press kind of thing.
Yeah, so the idea is, normally if you're kind of hand drilling something, you might use something like a center punch. You kind of,
Mm-hmm.
and it makes an indent. But if you're on a milling machine, you can do it more precisely by taking essentially a very stiff drill bit, I guess is one way to think about it, which makes a very precise divot. So first was that, after kind of clamping this into a vise. And then this is stainless steel, and I have a very small milling machine, a desktop one, which is really not very good for stainless steel. Have you ever done stainless steel before?
No, no stainless steel.
Have you done aluminum?
A little bit.
Okay, so with aluminum, one of the big things is as you put, like, say, an end mill or drill bit in, it's very, like, if you push the drill bit in, it will just kind of knock some chips out. But stainless has something they like to call like a bite to it. Like, it can be really hard to get going. And then once you're going, you really just want to keep going because it can be hard to get that edge again. Does that kind of make sense?
Okay.
So that is one of the really big challenges to this. In order to do that, you might need a lot of torque or force, something that my small machine can't do very easily. So what I did was I started with very small drill bits, and I kept incrementally increasing them so that the force on the machine was relatively small. And by keep increasing this hole larger and larger until it just matched this pin size, I was able to get something that very snugly fits in there.
Okay, so that isn't tapped in. It's just a straight up hole.
That's right. It's just friction fit. In fact, my original plan was to maybe use wax to affix it in there if it was a little bit loose, but the hole was drilled so precisely that I actually had to press fit it with a vise. And that's how it's stuck in there right now. There's no glue or anything. It's just friction fit.
Okay, very nice. And for the drill bits, did you use special like steel drill bits?
So I was thinking about this. So ideally, I would want to use cobalt drill bits. You might hear grades thrown around like M35 or M42. And those are really good for stainless. So what I have though instead is I have high-speed steel, which is not ideal, but it does a pretty good job. I have two sets here, which I don't have handy, but one of them is like, let's call it the Home Depot set, and the other one's the high-speed steel set. I tried using the Home Depot set initially, and it really couldn't even take a bite out of this. But the higher quality high-speed steel wasn't ideal, but it did a pretty good job at boring a hole in here. And so that seems to work.
Okay, very cool. How precise does that hole have to be? Like, does it have to be dead on straight? I mean, it doesn't look like you did a lot on that front, right? To like make sure it's exactly perfectly straight in.
No, so what really matters is that this point here just needs to be roughly concentric with the center of this. And so as long as you're roughly in that ballpark, that's all that matters. So there's actually quite a lot of slop that you can have on where this hole goes. The only thing that's important is this needs to be very, very, very rigid. So as long as it doesn't move, you're good. But anything other than that, you have quite a lot of slop on.
Okay, cool. And I assume you've tried this out and checked it?
Yeah, so I think this is probably a little bit out of scope for this video, but maybe I could have a teaser. So over here, you can see the actual machine, which has just undergone a whole calibration process. I've checked out everything, everything's within tolerance. And that specimen that you saw me holding is actually my very first test piece, which I'm preparing to put on the machine. And that's going to use this precise, they call slurry, if we can get that into the camera there. Unfortunately, I can't see it, but I think it might be in range. And what that's called is a chemical mechanical polishing solution, which will allow me to very precisely remove material from chips like the one you have on here.
You mean scratchy goo?
Yes, scratchy goo. Yes, that's right. It's like, yeah, it's like, yeah, just keep rubbing it, and that goo does magic. Instead of having sandpaper, that's actually a good thing probably to emphasize, is, probably most people that do something like this, like you've used sandpaper, right?
Yep.
But have you ever used like Dremel polishing paste as well, which is another way you can do things?
No, I have not.
Okay, well, but have you seen them? Well, anyways, they exist, and it's closer to that. It's you're not using sandpaper. It's not using that polishing pad that was on there. It's actually the snot or the goo or whatever you wanted to call it that you're just kind of throwing on there, and that's what actually does the polishing action.
Okay.
Shiny,
Very
shiny.
cool. So this is your first sample that you're going to put on. So you haven't actually ground down anything yet.
That's right. And what I've chosen here is something very large. What you're actually looking at here are two memory chips. I think DDR or DRAM, something like that, that I've put next to each other to make them even larger, because the larger the object you have, the easier it is to stay planar. And this will allow me to do initial checkout of the machine. And if this gives pretty good results, then I will move it to something more critical, like a microcontroller or something like that someone actually might want to get some data off of.
Okay. You're not using one of the parts we milled for this test?
So for the very first one, I'm going to use one of these. I did do some precision checks between this and this, and a quick assessment is these are about, I'm going to say 40 micrometers tolerance between one side to the other, which is within spec. So the exometry spec is about 50 micrometers. So it doesn't violate any specs. In order to use these, what I would have to do is do a so-called face-off. And what that means is I would use this more precise part to align the machine. And then instead of grinding a chip, I would grind the fixture itself. And the machine itself would basically very precisely grind away these edges. And then I would get a trued surface that I could use on the machine. So I probably will do that, because especially what happens is I might have multiple samples I want to run. I don't want to keep taking it off of this. So I will do that, but just not during initial machine bring up.
Okay, very cool. Yeah, I'm looking forward to actually getting that part like running and seeing how it performs.
Well, don't forget, it's already running. Your part was used to actually do the machine calibration.
So, and that went well?
Yeah, it seems to work well. It's very secure on the machine. I was pretty happy with it. Yeah.
So one thing we were deciding initially when we were going to CNC the part was whether we use steel versus aluminum, right?
Yes.
And I think we chose steel because it's a lot stronger, right? I guess it has less give.
So for me, actually, one of the big things was when I started this project, I thought that I was going to be able to use diamond or like polishing, they call abrasive films. So kind of like sandpaper. But as the project went on, it became clear that I had to use these slurry solutions. So that's this stuff like this right here. And the issue with this is that this is corrosive. So a lot of materials don't do well in that environment. And my understanding was the basic nature of that solution would destroy aluminum if it was used.
Okay.
And so that's the main reason to use stainless, I believe, is it's due to its superior corrosion resistance.
Okay, very cool.
Yeah. Well, this is maybe a good stopping point. I do have one last public safety announcement. During this project, I had to drill the steel, which I proceeded to pull away with my bare hands from the drill. So just a reminder, please don't do that, or you may get an owie. So.
Ouch.
Yeah. All right. Well, thank you for listening. And I think with that, look forward to seeing you next week.
Yeah.
Do you want to? All right.
Definitely. And I'm going to sign us out. Please like, subscribe, and share. Leave a comment. And, look forward to seeing you next week. Bye.